So what we have talked till now is the mechanical energy storage system, electrochemical energy storage system, chemical energy storage system, electrical energy storage system, and then we will talk now the thermal energy storage system. So the thermal energy system, when we talk about, so there is something we can directly utilize from the solar itself, and that are basically two types. One is sensible heat storage and then latent heat storage. When I say sensible heat storage, that means the temperature change takes place, and when we talk about latent heat storage, that means phase change takes place, solid to liquid or liquid to gases or gas to liquid and liquid to solid. When I say sensible, it is only temperature 5 to 10 degree or 20 degree or 30 degree that changes, phase does not change. But when we say latent heat, that means phase change, temperature does not change much there. Many of the times the combination of both are also being used, sensible heat as well as latent heat storage. Now this can be used directly from the sun also, especially on the heating application, wherever we have a heating application. So this type of storage can be directly utilized through the solar energy. There is another way that you generate the electricity from the solar and then utilize that electricity to produce a thermal storage. So a heat storage system that uses a heat storage medium. This heat storage medium could be anything. It could be water. Water is excellent heat storage system because of its heat capacity and the availability. That makes excellent choice for the heat storage medium. Now, where the addition or removal of heat results in change in the temperature. So whenever I try to take out some heat, that means temperature will drop. Whenever I will add heat, temperature will increase. Latent heat, whenever I try to take heat, phase changes, maybe from liquid to gas, from gas to the liquid. Whenever I add heat, then again phase will change from liquid to the gas or solid to the liquid. So that becomes latent heat storage. So a diagram here, the portion from here to here is a sensible heating. Now from here to here it is a latent. Again from here to here is, so here from solid it is getting heated up to this. Now it started forming to the liquid. Up to here it is only in liquid form. Temperature does not rise. Now again, that means whole solid gets melted till this level. Now the temperature started rising. Now the whole liquid is going to the higher temperature. Now there might be another option here that liquid is getting converted into the gas here. So the sensible storage will work from here to here, latent storage will work from here to here, again sensible storage will work from here to here, and then at the final the latent storage may work from here. Again there would be sensible heating, that we say superheating. Okay. So when I say the solar thermal energy, then it depends upon the what is the solar radiation, the nature of the thermal process, physical and chemical properties of the storage medium which we employ. I can employ wax also as a storage medium for a latent storage. I can employ phase change materials as a storage medium. So depend upon the storage medium we can utilize this there. Now chilled water system, and this is what we are utilizing in our IIT Madras Research Park. So we have a 300 cubic meter storage capacity. We chill the water to the 6 degrees centigrade using the chiller whenever we have excess energy available, excess renewable energy available, and we utilize this chilled water to run the HVAC system on the regular basis. Whenever I have a regular renewable energy, I keep on running the chiller to run the whole HVAC system. Whenever I have excess renewable energy, I start chilling the stored water to the 6 degrees centigrade. it could be lower also, but since our system efficiency and other things has been worked out based at the 6 degree chilling, so we use 6 degree chilling capacity. The return water temperature is 20 degree. That means if when my whole tank is at 6 degree, whenever I had excess of renewable energy, I can circulate this chilled water to the whole building for whole HVAC unit, and the return water temperature comes to 20 degree. So what is the energy storage capacity of this system? E equal to, or E storage I say, or otherwise you can use Q, is MCP delta T, where mass of water is nothing but 3 lakhs into 1, 3 lakh kg. Cp of water is 4.2 kilojoule per kg per degree centigrade or per degree Kelvin. And then what we have delta T? Return water temperature is 20 degree. My storage temperature is 6 degree, so 14 degree. You multiply all those things, you get the thermal energy storage capacity. Now, if you have to convert this into the electrical equivalent, what you will do? You need to find out the system COP, refrigeration system COP. On an average, it works out to be 2. That means half the energy you have consumed to transfer the heat from 20 degree to 6 degrees. So, if my thermal energy storage capacity is 1 megajoule, my electrical consumption would be only 500 kilojoule for that one. And it works out most of the time an excellent energy storage, especially for the commercial complexes, industrial complexes, where 40% of the energy is consumed in this. So, whenever I will have excess energy, instead of putting as a storage in the battery energy storage or something like that, I can always store, because water is very cheap and you are not contaminating it or consuming it. So, once you have stored, only because of some evaporation losses and other things, only a small amount of makeup water you have to keep on utilizing, and it has very good, water being a medium, it has a very excellent heat capacity. It is the best in all available material. Now, the same water storage right now, which is right now 300 cubic meter, I can utilize it to convert it into ice also, and in that case by the same energy storage capacity would go almost 100 times more, or I can reduce the volume by 100 times less. So, both way it is possible. So, the latent heat capacity has a very high energy density, power density is also very high. The only thing is that heat transfer between one medium to other medium becomes slightly slow because of the change of the thermal conductivity, or you can say mixing. Thermal conductivity also does not change much, but the mixing surface area gets much reduced, which is much better in the form of liquid. You can send it to anywhere, transportation becomes difficult, but the capacity wise it becomes much smaller to provide the same capacity when I use the latent heat capacity there. So, chilled water storage, what we use, sensible heat capacity, most economical system, most of the time 200 tons hours it can give you the capacity, a very small volume. If you want to further reduce the size, you want to increase the energy density, however at the cost of reduction of the power density, you can utilize this as for latent heat of fusion, where whenever you have excess renewable energy, utilize it for this chilling the water, which can be directly circulated for the HVAC operation whenever you have deficit or no RE. The only problem is that this system will gain the heat, but that can be minimized using the proper insulation. Initial investment is very low compared to any other type of energy storage. in this type of system, and the life is very long. You can run number of cycles per day without degrading the performance of the storage. The cycle life is very high, much more than any other storage system what we have looked upon right now. Smaller equipment can be used in the localized basis. Significant reduction in time dependent energy cost, a good energy saving, efficiency is as high as 90% of this type of storage, round trip efficiency. Ice storage uses 15% more energy than the conventional energy system. So that's what I say, around 85% energy efficient. And there is a heat gain in pipes and other things which can be minimized by using the proper insulation. So with this, I will summarize the whole chapter 10. We have talked about various type of energy storage system: mechanical energy storage system, chemical energy storage system, electrical energy storage system, thermal energy storage system. What we have talked: pumped hydro storage for mechanical, flywheel energy storage, compressed air energy storage. Then we have discussed in chemical energy storage, battery energy storage, regenerative fuel cells, redox flow cells. Then we have talked about superconducting magnet energy storage, supercapacitor in electrical energy storage, and then in thermal energy storage, sensible heat storage and latent heat storage. These all are options for energy storage, and from where this energy is coming? For us, it should be from the renewable energy. What are the services of energy storage technology? Why it is important? For load regulation, contingency reserves, load following, capacity supply, transmission and distribution loss reduction. So for these things, we require energy storage, the type of energy storage. So with this, chapter 10 is over. Also this course is over, and we may have one or two guest lectures by eminent professional in this particular field. Any question? If no, we can close this. Thank you very much.